Hello guys, I hope you all are doing good. I am Vaishali Kikan and we are discussing the electronics engineering. Today in this video, we are going to talk about the second configuration of the diode, that is a parallel connected diode or the parallel configuration. Right, so today we are beginning with the next type of configuration. What is the application? Why do we have this configuration? What are the different properties of this configuration? All of these things we are going to look in this video. So let's start our discussion. So what is a parallel configuration? The diodes, as the name suggests, are connected in the parallel in the circuit. So we will be getting a parallel configuration. So components are connected across each other having the two common points. Like in the series configuration, we were having only one common point where they were connected. Here we will be having the two common points. So here you can see at this point as well as at this point the two diodes are connected, but when we had the series configuration, the two diodes were connected at only one common point. So this is how you can differentiate between the parallel and the series configuration. So now coming to the properties of the diode which are connected in the parallel configuration. What are the properties of the different diodes or the different even electrical components which are connected in parallel? So the different electrical components, when they are connected with parallel, they will be having the same voltage drop across them, but they will be having the different current passing through them, and same goes true for the parallel connected diodes as well. So now when I have the parallel connected diodes, the current carrying capability will increase. So if I want to have a high power device, I want to have more current passing through it, I will be connecting more and more diodes in the parallel, right? So that the current carrying capability will be increased for the given circuit. No conduction current would be there in the resultant diodes in the both of the sides, right? So conduction current would not be there. Now we have the problem of having the diodes at the different current. So the current passing through the diodes would be different. Here let's suppose we have ID1 flowing through the diode D2. Let's suppose it is ID2, and the current flowing through the diode D1 would be ID1, right? The total current which was flowing was I from the source voltage Vs, and now here we have the two resistors connected in the two parallel terminals as well. Now this is my steady state. Now if I want to have the same current in both of the diodes, right? If I want to have the same current in all of the branches, if I have n branches in the parallel, so what I will be doing, I will be taking the inductors and I will be connecting it in the parallel configuration. So inductors are connected to share equal current among the diodes. But now there is a problem with the inductors and using the inductors in the given circuit, because inductors are expensive, they are bulky, and they can even generate the spikes, which is a problem for us. So the parallel configuration will be having some problems due to the use of inductors, which was making the current flow in the both of the terminals same. So now how the inductors are controlling the current when the ID1 increase. So let's suppose here we have the ID1. When the ID1 increase, the voltage drop across L1 will be increased, because the voltage drop is directly proportional to the current flowing through the inductor. So when the voltage drop at the L1 increase, we will be having the opposite polarity at the L2, and this is how we can have the higher current flowing through the diode D2 as well. When the L2 is having opposite polarity, it will be passing more of the current, it will be stopping or it will be providing hindrance to less of the current, and more current will pass through the diode D2, and this is how we can regulate the current in between the two diodes. Now the parallel diodes will be having the same reverse blocking voltage, right? The reverse blocking voltage is not a problem over here, because the diodes are connected in parallel. They will be having the same reverse blocking voltage. All of the components which are connected in the parallel will be having the same voltage. Now we have to have some precaution while using the diode with the same forward voltage drop, right? Because here what we are using the diode with the same voltage drop. in the forward direction as well. When I am using the diode with the same forward voltage drop, so I will be having the precaution that some heat will be sinking off the diode, and thus we require the coolers also. So coolers are equally necessary when I am using the parallel connected diode due to the generation of high amount of heat. If you do not use coolers, if you do negligence of the coolers, so the changing diode temperature would be there, and the diode temperature would be changing unequally in all of the diodes. When we have different diode temperature, we know the current also depends upon the temperature, so we will be having the different forward characteristics. The current, the voltage, everything depends upon the VT, right, which depends upon the temperature. So when the temperature change, the forward voltage change, forward current change, and this is how the VI characteristics change, and it is going to cause the problems, right? So we have to always use the heat sinks. We have to avoid the inductor problems. We can see if there are some spikes generated due to inductors as well, and we have to overcome it. So these are the problems that we have to tolerate. Otherwise, the parallel connected diodes are going to give me very high power. It is going to be used in high power applications, and it is used to match the desired current ratings as well. So this is how I am concluding my parallel connected diodes. I hope you understood each and everything that I have talked about in this video. If you have any doubt, you can put the doubt in the comment, and I will be trying to resolve your doubt as soon as possible. I hope you like this session. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. Thank you so much.